Hi, I'm Keith Baker, and today I'm going to talk about failing to learn the basics. As usual, I have a couple of caveats. Firstly, I will make some simplifications in how I describe the studies, just to get you the gist of the information and not bog you down in details. And secondly, if you want those details or more information, please see the references at the bottom of each slide. First, we're going to have a look at how doctors perform when they do or don't encounter failure, and we'll see how much they learn when they do or don't encounter failure. These residents are going to be anesthesia residents in their first year of training, so they don't yet have a lot of experience in the operating room. They're going to be brought to the simulation center, and they're going to be managing simulated pipeline contamination, which is to say the oxygen hosing is going to be contaminated with nitrogen, which is incompatible with life. These first-year residents will be randomized to one of two conditions. In the top conditions, they're going to have to handle this scenario of a contaminated pipeline all by themselves. They will not get help from the attending anesthesiologist. It turns out, since they can't handle the situation, the simulated patient is actually going to die because they're going to fail on every one of these situations. The other group, on the other hand, has a readily available attending anesthesiologist who will come in and help them manage this simulated pipeline failure. In that case, of course, the situation will be solved, the attending anesthesiologist will help them figure it out, and no harm will come to the simulated patient. Importantly, at the end of the simulation, all of these people will be debriefed, and how to manage and identify the pipeline scenario for the future will be explained in great detail to all of these residents, so they all get the same learning at the end of the process. In addition to getting debriefed and learning all about what to do and how to manage a pipeline failure, they will also be asked whether or not they think they would have figured out the source of the problem on their own in time to help the patients. And you can see here, we have our independent group right here, the group that failed. They failed 100% of the time. Their simulated patients all died. The other group was supervised, and they had 100% success. So the question is, which of these groups will realize that they did or did not have the ability to solve this problem? You can see here, perhaps not surprisingly, that the group that failed all realized that they would fail because they actually went through the process and failed. In contrast, in the group that received some help, many of these people thought they would solve this problem all by themselves, when really we know for sure that when nobody came to help them, they would have actually failed, probably at the 100% level. So we can see people have fooled themselves in this circumstance. Now, about 6 months after this simulation, all of these residents are going to be brought back to the simulation center, and they're going to be exposed to a completely different scenario, but they will also be exposed to another pipeline contamination. Again, this is going to be unsupervised for all of the trainees. Now we're going to take the group that previously was independent and failed, that's this group here, and we're going to ask the question, compared to the previously supervised group that was 100% successful, which of these two groups was able to manage this new, fully unsupervised circumstance in a successful manner? We can see here quite a difference in outcomes. The group that had previously failed, this group here, was far more successful than the group that was previously helped by the attending anesthesiologist. Let's move on to see if we can fail to learn in something like math or physics. This is an experiment here with these students. They are young people. You'll see here that they're in high school, and they're going to be randomized learning about the standard deviation, or what's called variance in groups of data, and how to solve this problem. The first group is going to get direct instruction. This is a classic lecture. They will be told how to compute the standard deviation for a group of numbers. Then they are going to be given a problem. They're going to be asked how many different ways and how many different techniques can they list that will describe the variation in a group of numbers. The standard deviation, of course, is one of those examples. You can see that 100% of these students were successful in generating the standard deviation because they had already been taught it. In contrast, the other group is going to be randomized to this problem-solving task first. They're going to be asked to describe as many different techniques as they can come up with in their own mind for describing scatter or variation in data, one of which, of course, is the standard deviation. Not surprisingly, these students in high school who have not had this before all fail to generate the concept of a standard deviation. After that, they will be getting the exact same lecture as the other students got before. This is the exact same 1-hour lecture on how to compute a standard deviation. The next question is, how many solutions did each of these groups come up with when they were asked to generate ways to describe variation in groups of numbers? You can see here, despite the fact that this top group was given a lecture on how to compute the standard deviation here, and could actually come up with the standard deviation when it came to one of the solutions, they did not come up with as many solutions. They came up with 3 different ways to describe variations in number. In contrast, the group that struggled and failed down here came up with nearly twice as many descriptions of how to describe variations in numbers, one of which was the standard deviation. I do remind you that none of them came up with a standard deviation at this point in time, so had they known the standard deviation, that would have been even one more, bringing them up to 7. So there's something about failure that leads these people to come up with more creative ways to describe the problem. They then had these students engage in a transfer test. In other words, they asked them to do a new but related problem. And again, you can see that the students who had failed initially ended up transferring these results to a new problem set much more effectively. When they asked the students about the conceptual understanding of the test results, in particular the standard deviation, again, you can see the students who initially failed, this group down here, was far more successful than the group who was literally told the answer. In addition to mathematics, another study was carried out with Newtonian physics. It's a fairly complicated study, but the same essential findings were obtained here. These were seniors in high school, and they were advanced students of a very high caliber. And they found here, those who failed and struggled were much more successful at generating better and deeper understandings. So from this, you can see that there is a distinct advantage to failing to learn. Thanks very much for coming along on this short walk on the Expert Pathway.